So, what is auto machine learning and what is this for? Automated machine learning is the process of automating the end-to-end stages of a real machine learning workflow. Let's review what are the stages of a typical machine learning project. Let's focus on the right side of the slide. You can see that there is a chart that represents all the stages of a typical machine learning process. A typical machine learning project starts by doing data collection. This process requires the practitioner to go into real-life settings and set up the proper tooling in order to get data. Sometimes this can be done automatically, but sometimes it requires field work, like executing instruments as surveys, interviews, or exams. Data needs to be collected in a format that can be easily processed, stored, and retrieved. And this is the main reason why machine learning datasets usually exist as comma-separated value files, or they also exist as tables stored in relational database systems. Well, once we have a dataset that contains the data that we want to use for the training process, we should move into the first preprocessing stage. That will help us to guarantee that we will be using a meaningful dataset. In this stage, the practitioner usually cleans up the data. So we use this step in order to remove null values or empty values. Sometimes we have to give default values to some attributes that are required for the training process, but for some reason don't have a valid value in our dataset. Sometimes we have to eliminate values that are very atypical and that we recognize that are the result of faulty processes. During this stage, manually exploring data using visualizations to realize the shape and the trends in the data and running the scripted statistics are the main tasks. The next stage in the workflow of a real machine learning project is taking some time to think about sampling data. For those projects where there is a good amount of data, this is those projects where we have a lot of records that are representative for the problem that we want to solve. We can do sampling. By doing sampling, we want to split the dataset in two sets, one training dataset and one testing dataset. And this is different of doing K-fold cross-validation, for instance. The reason is that we can still do K-fold cross-validation also with our training dataset. Here, what we are doing is to select some samples out of the records to create a dataset that it will be completely not taken into account during the training process. Of course, you can do this if you have enough data. Otherwise, you will better like to use all your data in the training process and then do and execute a validation technique like K-fold cross-validation to guarantee some level of generalization. Well, the next stage in the workflow is to properly select or create the predictor variables from and out of the data. This is what we call feature engineering. Feature engineering is the process of creating individual and measurable properties that are at the same time informative, discriminating, and independent. This step is one of the main steps in the workflow because it is related to finding the explanatory variables of our dataset. Once the features of the data have been identified, the practitioner should execute the training. To, to be able to train a model, the first thing is to know what model are we going to train. So the practitioner has to take into account several aspects in order to select what model is going to be used for the training process. Those aspects include but are not limited to the nature of the dataset, whether our problem is a classification or a regression problem, the data types of our features, the complexity of the model in terms of interpretability and computer power, and then of course the performance of the model itself in terms of prediction. Well, then the model is trained. Training data is provided to the training algorithm, and most of the training algorithms require some values, some constant parameters to be defined before the training process starts. We set values for those constants and we let the training algorithm run, and then we obtain the model based on the data. But the performance of the model is also dependent on the set of constant parameters that we define before the training. Those parameters are called hyperparameters. The optimization of the model based on those parameters is what we call hyperparameter optimization. After the model is obtained, we move into a post-processing stage, which is evaluating our model. This task includes taking metrics, running different sets of evaluations to measure how well our model is doing regarding aspects like generalization, overfitting, precision, accuracy, computing time, interpretability, the confusion matrix if our problem is a classification problem, and so on. Here, our model if our model doesn't give the expected evaluation measurements, we have to get back to the previous stages like hyperparameter optimization or model selection or feature engineering, obtain new parameters, new features, or select another model and execute the training process again and continue looping under this cycle until we get a model that meets our expectation. As you can see, this process is not easy. Each of the steps mentioned above have have been deeply developed by researchers around the world. There are dozens of techniques that can be applied at each step, and each technique has its own complexity and a learning curve that makes it hard and difficult to access to all of them. So let's think about how much time do you think it will take for a person to run a complete set of steps and be able to put in practice more than one technique per step? A lot of time, right? And a lot of effort. So as the complexity of these stages is often beyond the machine learning beginners, the rapid growth of machine learning application has created a demand for off-the-shelf machine learning methods that can be used easily and without the need of expert knowledge. We call the resulting research area that targets this automation of the machine learning process auto-machine learning. And the main idea for auto-machine learning is to first, to automate the machine learning workflow so that it is more accessible to unexpert people, and to find better models by doing exhaustive automated optimization process.